from the new cubicle and plug them into where your old pair of wires used to be plugged into, or sit down at this computer we call a telephone switch and tell it that that network address, person, and services should be associated with this new pair of wires, not the old pair of wires. That costs money and takes time. In IP telephony, the IP phone is an IP computer, just like your desktop is, and it runs on a LAN, and it runs the dynamic host configuration protocol. So when you change cubicles, you pick up your IP phone, you unplug the LAN cable from the LAN that's plugging it onto the communication network, you walk over to the other cubicle and plug it in, and then this IP telephone runs the dynamic host configuration protocol. It re-registers at the IP network level, and then it re-registers with the gatekeeper doing the registration, admission, and status functions, and poof, the network knows where you are and automatically redirects the phone calls there. You see, on a LAN, if we don't want to get too far into the details, it doesn't matter where you plug your cell phone, it's position independent. And then we've got these software programs that automatically re-register you at the IP level and at the voice over IP level, so we do not need technician intervention if you want to change cubicles. And that might be a savings of $100, $150 a year per line, which adds up pretty quickly in a big office. All of this is true, except if there are some special features that have to be manually programmed when you move. Let's say you change jobs, for example, and now all of a sudden you're in the sales department, and so you're part of a hunt group. So if somebody calls a number, you know, the theory at your company is that a phone always gets answered. Well, if it starts ringing here and nobody answers, then it camps on here and it goes over there. If you're now going to join that group, somebody would have to manually program that in. Or if you're as part of a call pickup group, so the person in the cubicle 2 over, their phone rings, you can pick up your phone and punch *71 or something like that, and you'll answer their phone. That would have to be manually programmed as well. But other than that, you get free moves and changes with voice over IP, which is a big advantage. Save money on building wiring. The premise here is that we can vaporize half of the infrastructure for in-building wiring. Traditionally, we would have one set of wiring for the PBX and one for the LAN. And what we're going to do is we're going to unplug our telephones from the PBX wiring and plug them onto the LAN instead. That means we can get rid of all of the infrastructure associated with the wiring of the PBX. And that includes the distribution frames, the riser closets, the technicians, the inventory, all of that stuff. Just get rid of it and use the LAN instead. Now that all sounds great, except powering the phones. Now traditionally, telephones are powered over the telephone line. Your phone at home is powered by the telephone company. There's minus 48 volts on there. And traditionally, with PBXs, the telephone is powered over the telephone wires as well. Now, it is possible that you've got a PBX or Centrex phone where you have a little transformer, one of those black things you plug into the wall, and it converts the 110 volts in the wall to 48 volts, and then plug it in and run your telephone. If you've got one of those already, then this whole discussion I'm about to have is moot. But most of the time, the PBX telephones are powered by the PBX over the PBX wires. So we have to start thinking about, well, how are we going to power telephones over the LAN wires? Well, there would be a number of ways of doing that. And one way of doing it would be to not power the telephones over the telephone wires, but instead give everybody little black transformers that they plug into the wall, and then they plug into the phone, and it powers the telephone from Con Ed or wherever your electricity company is. Well, there are a couple of questions then. One of them is, are there enough electrical plugs in every cubicle to be able to do this? And in a couple of cases we looked at, the answer is no, there aren't enough electrical plugs to be able to do that. And it's now getting away from the idea of one wire to the desktop. Now you've got two, one for power and one for communications. And it might also be possible that you don't want to do that for availability reasons, because the electrical power supply has one availability and reliability criteria. Your telephone system has a different one, and now you're using the weakest link in the chain to do both things. So we decide, okay, we are going to power the telephones over the LAN. Now how are we going to do that? LANs were designed for data communications, not for carrying minus 48 volt DC to power telephones. Well, it turns out that for 100 megabit per second Ethernet and 10 megabit per second Ethernet, this is called fast Ethernet and 10 base T, or 10 base T and 100 base T, you might hear this called. It turns out that not all of the wires in the LAN cable are used for doing data communications. All LAN cables have 8 wires in them, 4 pairs. And in 10 base T and 100 base T, only the center 2 pairs are used. The outside 2 aren't used for anything. So, if we have metallic continuity from a wiring closet to the desktop on those extra pairs of wires in the LAN cable, then we could put equipment that puts 48 volts on those extra pairs and gets it to the desktop over the LAN cable. And that certainly is reasonably easy to do. The condition here is you have to have metallic continuity. So that means right from the wiring closet where you're going to put this power converter and injector device right through the desktop, the wires are metallically continuous. So in other words, it doesn't go through any hubs or switches. So that might be true and it can be implemented. But the premise of that discussion was that we're using 10 base T or 100 base T. What happens if we decide to go to gigabit Ethernet? Well, it turns out that gigabit Ethernet uses all 4 pairs in the cable for doing data communications, and there are no spare pairs. So we can't put minus 48 volts DC directly onto gigabit Ethernet. So if you wanted to use the idea of using spare pairs to carry power on the LAN to power the telephones, you would also have to say we are never planning to move to gigabit Ethernet on any of this part of the LAN. Well, when you buy a computer today, there's shipping with gigabit Ethernet cards in them. And just like we had to change from 10 megabit per second to 100 megabit per second, there's going to be a change from 100 to gigabit Ethernet. And 5 years from now, everything's going to be gigabit Ethernet. And you've gone out and deployed a voice over IP LAN technology that prevents you from doing gigabit Ethernet? I don't think so. So then we start looking at, okay, we're going to do gigabit Ethernet. How do we power the telephones? Well, it turns out that there is a scheme where we can use transformers to isolate the LAN card from the LAN cable electrically at the DC, that's direct current, steady state level. This is called phantom powering, which is kind of a strange name. If you wanted to talk about it in an electrical engineering sense, it's isolating the equipment from that DC voltage on the wires using transformers at each end. Now, this is all fine, and it can be done, but the problem is, what happens if there isn't a transformer on the other end? In other words, you've taken your desktop PC with a gigabit Ethernet card that you bought 2 years ago and plug it onto this LAN that has the phantom powering. So at the wiring closet, we've got the data signals and then a little transformer, and it puts minus 48 volts on there. That goes to your, what we might call legacy LAN card that doesn't have any little transformers on it, and the minus 48 volts goes poof and blows up the LAN card in your desktop computer. Well, then what we need is a device that can scan your LAN, and it puts a little tiny pulse of electricity on, and for those of you who like details, looks for a particular resistance signature on the other end of the wires to tell whether that's a LAN card that has a transformer or it's one that doesn't. And if it figures out that that's one that doesn't have this little transformer on it to isolate this DC voltage, then it doesn't put the powering, the phantom powering, on that particular lamp.